Alright, class. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan selamat pagi kepada para hadirin sekalian. Terutamanya yang dihormati Puan Rosina binti Ahmad, Pengetua SMK Seksyen 9, Puan Nur Fazilah, Wakil dari pihak JPS, not forgetting our respected guest speakers of the day, Dr. Izha Aziz, Professor Dr. Madia Muhammad Hussein, and Mr. Wan. I'm Wan Kistina.
And I'm Irina Wanzul, and we will be your moderators for the day. Many of you here may or may not know us. For those who are new warriors, we're from Keris Racing and F1 in Schools team from SMK Section 9, Shah Alam, 2020's F1 in Schools Virtual National Final Champion title holders. And for our new warriors that joined us last premiere, welcome back.
Before we can invite you to join our next journey to the World Finals, we have prepared a short summary of the previous chapter to our story, Our Road to Nationals, for you to follow along.
We have a team that is representing SMK Section 9. Now this team is actually called Keris Racing.
Keris Racing.
Hi, my name is Irina, and this is and we're from
Keris. I said back foot malam. Keris Racing.
While you and me repeat, this bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire. just can't stay still. Don't stop that thrill. My bones crave your skin. Temptation within. Mistakes ignite the silence. Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire. Yeah.
Wow. So first of all, I'd like to say thank you for 100 views. I hope you guys found that somewhat intriguing. It was kind of hard finding the footage because most of our journey has been through a screen. Anyway, our story doesn't end here as the chapter of our journey to the World Finals has just started.
Also, we would like to thank everyone here today for joining this journey with us by being a part of our second episode of our webinar series, Inside the Mind, with yours truly, Keris Racing.
The motive behind this webinar series is to share experiences and knowledge on various aspects of that correspond with this prestigious competition to a wider audience. So welcome to the second episode of Inside the Mind, entitled Visionist of Innovation. As you can probably tell by the title alone, the theme for this episode is innovation.
But before that, saya ingin menjemput Puan Rosina binti Ahmad, Pengetua SMK Seksyen 9 Shah Alam, untuk memberi sepatah dua kata pembukaan. Dengan segala hormatnya mempersilakan.
Terima kasih pengerusi majlis Kristina dan moderator kita Erina. Alhamdulillah. Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera saya ingin ucapkan kepada semua barisan penceramah, barisan anak-anak Keris Racing ya. Alhamdulillah, syukur kita kepada Allah Subhanahu Wa Taala kerana sekali lagi kita dapat bersama-sama mengikuti siri webinar Inside the Minds episod 2 bertajuk Visionist of Innovation. Ya, alhamdulillah, tahniah juga saya ingin ucapkan kepada tim Keris Racing ya kerana berjaya sekali lagi berjaya meneruskan siri webinar ini masuk kepada episod yang kedua ya. Semoga melalui siri webinar ini semua yang mengikuti webinar ini akan dapat murid-murid dapat memperoleh pengetahuan yang lebih mendalam berkaitan dengan pertandingan F1 in schools ya, dan juga elemen-elemen sains yang berkaitan dengan kejuruteraan dalam menghasilkan kereta-kereta F1 inilah ya. Semoga ia juga dapat merangsang minat anak-anak murid dalam mengikuti pendidikan STEM ya, yang semua orang sedia maklum bahawa sekarang kita perlu merangsang minda anak-anak untuk mengikuti pendidikan STEM ya, melalui seperti ini. Mudah-mudahan ia dapat merangsang lagi atau berminat murid-murid untuk menyertai bidang STEM. Tidak lupa juga saya ingin mengucapkan terima kasih kepada barisan penceramah ataupun speakers yang sudi mengikuti menyertai kita ataupun yang sudi memberi sumbangan sebagai penceramah, iaitu Dr. Izhar Aziz daripada 3D Gen. Terima kasih Dr. Izhar. Prof Husin, Prof Muhammad Husin ya, kita punya mentor kita daripada UiTM yang tak pernah jemu-jemu ya, memberi bimbingan kepada anak-anak Keris Niners, dan of course finally one Muhammad Ishraf, our ex team members. I can't remember the name, ex-team members of the F1 in Schools yang mewakili Malaysia, saya rasa ke Singapura, pertandingan World Finals di Singapura. Terima kasih kerana sudi menyertai webinar ini dan memberi sedikit input tentang pengalaman-pengalaman beliau dalam menyertai pertandingan F1. Semoga majlis hari ini berjalan lancar dan semoga semua yang mengikuti siri webinar pada hari ini akan memperoleh manfaat, insyaAllah. Itu sahaja daripada saya. Sekian, wabillahi taufiq wa hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Pengatur. It seems someone misses you in the crowd.
Oh, is it?
And Rosina, we miss you from SMKTD.
No, is it really? Sama di mana? Alhamdulillah ada. Wah, ada siapa ni from SMKTD? I was the principal there. I was miss you guys too in SMKTD. Okay.
Alright, thank you so much, Roslina.
Thank you so much, Fred. Alright,
Thank you.
Alright, thank you. Moving on, saya ingin menjemput Puan Fazila, wakil dari pihak JPS yang turut membantu Keris Racing dalam menjayakan webinar ini untuk memberi sepatah dua kata. Dengan segala hormatnya, kami mempersilakan.
Okey, Assalamualaikum. Terima kasih kepada pengerusi majlis, okey, kepada Emina juga, okey, kepada tim Racing F1. Okey, kepada Yang Berbahagia Puan Roslina binti Ahmad, Pengetua SMK Seksyen 9. Okey, tahniah di atas penganjuran bersama dengan jabatan, okey, kerana pihak jabatan merasakan penting untuk kami memberi sokongan terutamanya pasukan yang pernah mewakili negeri Selangor ke peringkat kebangsaan. Tahniah di atas pencapaian yang membanggakan. Saya rasa pencapaian ini saya rasa berturut daripada tahun-tahun sebelumnya. Okey, saya mengucapkan selamat datang juga kepada barisan penceramah kita pada hari ini. Terima kasih kesudian bersama-sama dengan pasukan tim daripada negeri Selangor, okey, mewakili Malaysia untuk peringkat international, iaitu Profesor Madya, Dr. Muhammad Husin, okey, dan Dr. Izhar Aziz. Okey, sebenarnya program ini kalau ikutkan tidak dirancang bersama dengan Dr. Kashnani, tapi saya merasakan penting untuk jabatan membantu perluasan F1 kerana pertandingan ini kalau diikutkan kita tengok penyertaan tidak sepenuhnya daripada sekolah-sekolah dari negeri Selangor. Saya mengharapkan apa yang disampaikan oleh pasukan melalui pengalaman yang mereka telah tempuh sepanjang terlibat dengan F1 sedikit sebanyak dapat menarik minat sekolah-sekolah lain dan sekolah-sekolah lain boleh tahulah sumber mereka untuk dapatkan maklumat mengenai F1 dengan lebih jelaslah. Okey, saya mengharapkan program ini dapat dijalankan dengan baik sehingga ke akhirnya, sebab kita ada dua lagi siri pada akan datang berakhir pada hujung bulan 4. Okey, insyaAllah pada masa yang sama apa yang jabatan boleh bantu adalah penyertaan bagi guru-guru bagi program ini. InsyaAllah kita boleh masukkan di dalam SPL KPM. Seterusnya penglibatan pelajar, nanti ada sedikit penerangan daripada tim bagaimana untuk mendapatkan penyertaan. Sekurang-kurangnya kena join daripada awal sehingga akhir supaya nanti kita boleh beri sedikit kredit kepada pelajar yang mengikuti webinar kita pada sepenuhnya pada hari ini. Okey, itu sahaja saya mengucapkan tahniah kepada tim dan good luck untuk next journey, okey, peringkat yang seterusnya. Okey, sekiranya ada masalah selepas ini, sama-samalah tim guru pembimbing dengan pihak sekolah boleh rujuk dengan jabatan, apa yang boleh kita bantu kita akan bantu daripada masa ke semasa. Okey, itu sahaja. Okey. Okey, terima kasih.
Alright, terima kasih kami ucapkan kepada Puan Fazila. Next, moving on, Arina Wanzul. Arina, sorry, but are you muted?
All right, I'm so sorry for that. I unmuted myself already. Oh, I see in the chat, wa alaikum salam. All right. Now, before we catapult into the event, I would like to kindly give a little disclaimer for all of you hungry sigil warriors. If you join one episode of the webinar, you will be receiving one appreciation e-certificate from Keris Racing. Now, in order to get a state level e-certificate, thanks to Pihat JPS, who is actually partnering with us, Keris Racing, with this webinar, you will need to join all the webinar episodes from episodes 2 to episodes 4. Don't worry, it'll be really interesting. And in order to qualify to receive all the e-certificates, we will provide a few simple questions that will be attached to the Google form at the end of the webinar to prove your attendance. So make sure to stay focused throughout the webinar.
Tidak terlepas juga kepada para guru semua, termasuk para guru di bawah jemputan pihak JPN. Saya ingin memaklumkan bahawa pada hujung webinar ini, kami akan memberikan link ke form yang akan membantu menaikkan mata SPL KPM anda.
So without further ado, we would like to invite our first speaker of the day, Dr. Izhar Aziz, that will be sharing a little bit about the revolution of manufacturing through 3D printing.
Dr. Izhar Aziz, an experienced R&D engineer with highly competitive technical expertise and in-depth knowledge in materials and processing areas, with a PhD in mechanical engineering from the University of Waikato, New Zealand. In Dr. Izhar's career, he started off working at Sirim Berhad as a CAD designer and instructor in 2003 till 2009, assisting in design and development of product concepts by engaging rapid prototyping techniques. Later on, in 2013 till 2015, he became the head of technical and business development for Siri Sedaran Berhad. Currently, Dr. Izhar is the director and founder for 3D Gen Sedaran Berhad, knowledgeable in new product and process development, standards and regulatory compliance, engaged in rapid prototyping and manufacturing technologies, particularly in biomedical device, appreciated for ability to lead research teams in developing breakthrough technologies to achieve company goals.
Hi and good morning, Dr. Izhar. You may take it from here. Remember, para hadirin, a Q&A session will be opened at the end of Dr. Izhar's talk. So please get your questions ready. That is, if you want extra brownie points.
All right, thank you, Christina and Irina. Very good morning to all. Assalamualaikum warahmatullahi wabarakatuh. My name is Dr. Izhar Aziz. I think Irina already mentioned about my background. So I'm the founder of 3D Gen Sedaran Berhad, a company, a technology company that use 3D printing technology. And we've been working quite closely with Keris Racing team to help them in this competition. Okay, today I'm going to talk about the manufacturing revolution through 3D printing technology. I'm going to share my slide.
All right, Dr. Izhar, we'll let you take it from here and we'll dismiss ourselves.
Okay. All right. Okay. Today, the title is a manufacturing revolution through 3D printing technology, and I'm going to divide my presentation into three segments, which is I'm going to talk about the technology itself, the ecosystems, and also the applications that we're going to use by using this 3D printing technology. I hope that within these 30 minutes you guys can grab the knowledge of the kind of amazing technology and how we can use this technology for any application that you have in mind. Basically, for this particular session is try to create a innovative product, innovative product that can be produced by 3D printing technology. There's a lot of hype about this, what we call a 3D printing technology, or also known as additive manufacturing technology. Some say that this technology captures the imagination of young people. One thing about 3D printing that you can actually build almost everything. As long as you can design it, you have the digital data or CAD data, then you can actually fabricate or manufacture the parts that you have designed. So it is inevitable that the more people you have knowing about the technology, the more likely you are to have a good idea. So you can actually realize your ideas, convert your ideas, any ideas that you have into reality. So what exactly 3D printing technology? There's a lot of names. I think for the last 4 or 5 years, the technology before this is known as the rapid prototyping technology. But during that time, this technology being used just for to create a prototype model. But due to the advance of the material and the machine, now we can have a rapid manufacturing, which is a functional end use part. Due to the concept of how it builds the part, the name is we call it additive manufacturing. Uh, Anything that you 3D models that you create, and then we're going to slice it, and then we're going to create layer by layer. So for that particular reason, it is also known as layered manufacturing or additive manufacturing. The process involved is quite straightforward. You have two main areas. This is the design part and also the manufacturing part. So any design that, any ideas that you have to create it into or convert it into a CAD file, and then you can transfer it to the machine and print out the components that you have. So you can get your final object in terms of with no limitation in terms of design. So additive manufacturing or 3D printing technology is actually a manufacturing technology. How you want to build things. There's a few main manufacturing technology. The first one, what we call a subtractive process. If you have something you want to do, you have to remove the material. That's what we call a subtractive process. Have a block of material and use kind of a machine to remove the material. And another process, manufacturing process, is that you need to have a platform, a mold, to create or to shape the components or the parts that you have. This is what we call a casting process. It is also a manufacturing process. And the last one is the 3D printing technology, which is a layer manufacturing process. You have no need tools, no need mold. You just create your design and transfer to the machine, and it print out things that you want in a 3D shape. So in terms of 3D printing technology, you have various types of 3D printing technology. If you have the opportunity to visit us, we are most welcome all of you to come and visit us and have a close look to this technology. Because this 3D printing technology have a powder bed fusion, there's a SLA type, there's a FDM type, there's a inkjet printing type. There's a lot of various different technology, but the concept is still the same, where it builds the part through layer by layer. So the difference in terms of the what kind of the medium or media that have been used as a material. There's a filament type of material that you've been seen before. There's a powder type of material, and they also have a resin type of powder. So, and a source of energy, they sometimes use light, sometimes use a laser, and also sometimes they use a light sensitive projector to actually fuse all this material. So in terms of technology, there's a lot, but the most common one is the what we call FDM or material extrusion. It is quite similar to a welding process where you have a heated nozzle, you have a filament that pass through the nozzle, heated nozzle, and it melts the filament and it starts to build parts layer by layer. But this particular technology has been used quite massively in polymer for polymer material rather than metallic material. So you can have a lot of material that from plastic, from PLA, from nylon, ABS, and it can build to a 3D printing object. This is the process. I'm going to show you the videos here. Okay, it will take a bit of time. Okay, as the video has no sound, so this is the process of the FDM printing machine. So the last part is that the support structure that you have to remove, wash, polish a bit, then you go, you get your parts. Okay. In terms of material, there's a lot of materials that you can use to actually generate or create your 3D physical parts. For FDM, it's quite easy to access, easy to get, because the even the DIY price machine is very cheap. So you can use a different type of material, but it depends on the machine itself, what kind of temperature that you can process or you can use to melt the filament. So FDM is good, and then we go to another technology, which is the SLA, which use a light sensitive polymer, and so you use a kind of a light or laser beam to fuse the material itself according to the cross section that you have in your CAD. So it builds parts through that. So this is also a video about the machine, how it works. So the importance of understand how the machine works, it's crucial. So you can actually choose based on the application that you want or components that you want to produce, the right machine. So every machine has its own limitation in terms of the print quality that you have, or in terms of the material that can be processed by the machine itself. So SLA can give you a very high resolution print quality compared to the FDM. FDM can give you around 150 micron surface quality, but the SLA machine can give you around 20 to 50 micron resolution. So the concept is the same, but they use a different type of material, which is the resin. And a light sensitive resin, I mean the light strike the resin tank, it will fuse the material according to the CAD design that you have. So is the same, but it's going to be quite fast because this machine didn't use kind of a print head like FDM, but they use a laser optical system to scanning the part. So good quality, but it will take longer time compared to FDM printer. Okay. So in terms of materials for SLA, you have a lot of materials that you can choose. If your application require a tough material, you have a tough ABS type of material, and you want something that's durable, you can have a durable resin. And all these components and this part can be used straight away as a functional, no longer prototype. So once you print out, you can use it straight away. So that's kind of advantage of using 3D printing technology. And the other thing is that you can actually use for even forecasting a part, because it doesn't require molding, mold, tools to be used in a 3D printing machine. You can actually create a part that can be casted with, like example, for the castable resin, you can use to create a gold ring or the type of metallic ring for you to use. So there's a lot of material that can be used. Even you can use a material that can be implanted into our body. So in terms of material, there is no issue. There is a vast of material that you can choose to use. And in case of you need to have a rubber-like resin, you can have it using the SLA technology. So this is part. And the third technology that I'm going to share today is the SLM machine, where it uses a powder medium to create your 3D physical part. So this particular technology is able to sinter or fuse metallic and also polymer material. Okay, so that's kind of a machine that can produce a metallic component. So you have no limitation in terms of design, so you can create any design that you want. And the key advantage of using 3D printing technology is that you can actually have a functionally integrated structure. You can actually have a solid part in each different areas that you want, a different density area or different density part in one component. So you can create a solid part and also a porous part in one component. So that's kind of very, very key advantage or key important features that 3D printing can offer you to build your part. So in showing one of these slides, that's showing how you actually can optimize a design or component by using 3D printing technology. You can have a different shape, different design with a similar mechanical properties or similar force strength that you want. So this is kind of advantage in terms of having a more economical product compared to if you have a solid part and use a lot of material. And one last technology I want to share today is that material shading. This is quite similar to the 2D printer or HP printer, Canon printer that you have at the school or at the office. It uses a cartridge of a different cartridge of material, and you can actually produce a 3D physical part. uses a nano nozzle and start to spray the material, and then the recoater or heater will actually fuse the material. With this kind of technology, you can actually create a multi-color or multi-material component. So this is kind of very interesting. This is only technology that can produce more than one color. If you want to use, want to create a different material or different color of a component, this is the technology that you have to use. So with this technology, not only for polymer, you can use it for a metal, to create a metal part. So how we do it? Okay, let's see how we can actually create a 3D physical part or functional part through 3D printing technology. Two key areas. First one is the design. You need to have a CAD or a digital data before you can start with 3D printing, or you can send data to 3D printing. The second part is the manufacturing part. So these are two kind of software that you need to master in terms of producing a digital, functional prototype or component that you want to do. The first one, let's say in this process, you want to have a lattice structure like this. This is the on the right side is the one you design your CAD software. You can use a lot of CAD software available. Maybe at school you can have a SolidWorks, Fusion 360, which is very powerful software, and also on a cloud system that you can use a Tinkercad that you can actually log in online. You can create your component online. And then the second software, this is the CAD or design software you need to have. And then you need to have a manufacturing software, which is the slicing software. So this software actually for free, Akura, you can get it, you can download it online to slice the component. Once you create a 3D CAD data, put it into the software and convert it into a slice data. So in this software also, you can actually play around how to orientate the components that you want and how to put the support structure. So with these two software, you can get your part. But there's one important thing that you need to understand is that there is a standard format that you can use to translate or convert the CAD data into a STL format first before you can send it into Cura to do slicing. So the process is quite straightforward and easy to understand. And there you go, send it to the machine, you can get your part. But what's next? Start to remove the support structure, which is the unnecessary part. The support structure has been used to actually for the overhand part. It needs to have the support structure for this particular technology to support the overhang part in your components. So there you go, you can get your part and use straight away. It depends on the material that you want to use. You want to use ABS, nylon, you want to use metallic powder, but you have to go through these two processes before you can get the part out. So the benefit of it, this is something that the before this, the production and how you want to create things is kind of hard, and you need to go to the factory, a big factory that actually can produce the part with a big machine, and it takes not hours, but it takes more than days to create one part. And in terms of the casting, to create a mold will take maybe 1 to 2 months before you can get your part out. But with this 3D printing technology, you have the ability to produce your part in-house in relatively very fast. So the production and consumption now become very close together. So like this particular case, you can create a prosthetic to help the kids with this prosthetic when they grow. You can create another one that actually which designed according to their anthropometry or their size accordingly. And most of the technology in 3D printing technology being used for mass customization. So this allowed us to have a personalized or customized product rather than to have a mass production product. It is not yet able in 3D printing to produce a mass production, but it is possible to produce a mass customization product using 3D printing technology. So, and this is one of the benefits that if they bring the 3D printer into the space and they can print out the tools that they want, and it can be used straight away. So this is very important for the aerospace industry to have a lighter rocket and to actually help them producing or creating the tools that they want in during their exposure in the space. And this is one of the they call it discovery, or not discovery, a disaster theme that bring a 3D printer to a disaster place, which is being hit by earthquake. So they bring the printer to help to print things like pipe, so that they can use the components or the parts that they print straight away to help them to survive in this kind of area. So there's a lot of things that due to the process that is quite straightforward, with the design that you have plugged into the machine, then you can get the 3D part straight away. So what we can do, the application is really, really vast, but it is really suits nicely with medical application, because medical application require a customization process. So each design or device is according to the patient itself. So it's a patient-centric business, a patient-centric application. So you can actually use 3D printing technology to produce the device or the implant that you have to do. In 3D itself, we produce a lot of custom implant that used for the cranial replacement. And it's quite recently we actually create a 3D bioprinter, which is to print a tissue or skin using a collagen material. And in terms of other industry, there's a lot of sector now have been exploring to use 3D printing technology. One of these, like Adidas, been used 3D printing technology to produce these shoes, and this is available now in the market. And also other industry that been used to create a titanium framework, frame bicycle, and also for the components of the car. So, and we locally we also produce quite a lot of new prototype in terms of using 3D printing technology. As you can see here, is in one of the Petronas kiosks. So maybe you're gonna see the new design of the pump casing, petrol pump casing. This one in a petrol station nearby later on. So there's a lot of things that can be used in terms of a different sector, which is in the automotive industry, and as the Keris Racing team that been used 3D printing technology to produce their components, the car component itself. So there's no limitation in terms of design and no limitation in terms of material, but it requires some sort of a processing phase or processing part to really get the specification that you need. But to create the part, to build a functional part is no issue using 3D printing technology. So this is some of the applications that have been used in the industry, and mostly I believe that being used quite extensively in medical industry because of the features in medical industry that more into a patient-centric or customization product. And the latest, I believe, in digital dentistry have been used quite a lot, which creating a clear aligners, creating a crown, even a bridge that or implant, dental implant, using this 3D printing technology. Okay, and this is what I mentioned before, the inkjet printer technology that can actually create kind of very stunning print quality and another advantage is that it can use a different type of material and also a different color, because the concept is that you use a cartridge, a different cartridge to produce a 3D physical part. So here you can see that how high resolution is the inkjet printer with the nano nozzle that can create a quite similar to our shape, our mimic of our face, right? So this is kind of using an FDM printers that can build a table or even a chair for use to be used straight away. And this is our recent exploration into to create a titanium frame MTB frame bicycle using our 3D metal printer technology. So hopefully by August we can come up with this MTB titanium frame, and we can have a look. Okay, so application-wise, is a lot, and you can go to any other industry to create, but you have to identify the application that require what kind of part that you need to produce, and then choose the right technology, right 3D printing technology to create the part, because every technology in 3D printing it is has its own limitation in terms of material and in terms of the print quality that can be produced by that particular machine. So one of it that we use 3D printing technology is that in a digital dentistry to create, and also for the orthopedic part. So these all components can be used and replace the bone, human bone. So it is a biocompatible material that you need to use. And in terms of for this particular implant being produced by a 3D metal printer, which is using a metallic powder. So you can choose a different type of metallic powder, whether you want a cobalt chrome or titanium metallic powder, and use this machine to produce the part. And this part can be used straight away into a human, to replace human bone. Having said that, it means that the mechanical properties that being produced by 3D printing machine, it is comparable. It is meet the requirement of the medical device standard. So it is strong as part that being machine, or strong as part as being using a casting. And last but not least, the advantage of the 3D printing in terms of a topology optimization that you can do, because you can actually incorporate a lot of different shapes and also a lattice structure that you can actually produce through 3D printing, because in 3D printing you can create an internal structure. So that kind of advantage can give you a benefit in terms of the application that they use, particularly for this item that is being reduced. But from 120 gram with a new design, you can get only 68 gram, half of it. So customization and personalization of the product also can suited nicely with 3D printing technology. So you can improve product quality and also kind of value added kind of in terms of incorporating ergonomic design. Yeah. So advantages, definitely you can have any design that you want. There's no issue on that. You can have a freedom in terms of design. Any design that you can create in 3D CAD can be printed using 3D printing technology. Speed-wise, if compared relatively with the machining or molding, it is quite fast. But you have to take into consideration your design shape, the complexity of the part compared to what you can be part that can be machined. So if in terms of 3D printing, it is quite fast from design to get your component within a days, within an hours, based on the depends on the size and of the component you have. You can get it within hours or days. And customization is another advantage. You can custom to any custom to your according to the other part of custom based on the patient morphology or anatomy. Toolless, no need any tools. Just send to the printer and you can actually create the part. Extreme lightweight, with incorporating a lattice structure, you can actually reduce more than I think 50% of the weight of the component. So, but still maintaining the strength that you want. And also no storage cost because you only made for order. Once you get the order, you bring it out and deliver to the customer. Definitely, if increased employment opportunity, if been used widespreadly, you need to have a technician, a designer to handle the digital workflow using 3D printing technology. These advantages definitely, people are being asking about the accuracy. Roughly, the accuracy is around 50 micron. But it depends on the machine that you use, whether it's a desktop size or industrial size of printer. Then the support material kind of really give headache to.
Hi, Dr. Isha. So sorry to jump in.
Okay.
We have 5 more minutes left of your slot, but don't worry, continue.
All right. Okay, it's about to finish. I think a few more slides. Support material. So this is kind of because every design, unless for the SLS machine, support is not required. But other than that, everything other machine require a support structure, and you need to remove the support material. So when you design, you have to consider how to actually remove the support material, and that kind of and the support material actually using the same material of the part itself. So you're going to be removed as a waste in your part. Limitation of raw material, definitely. Even there's a lot of material, but sometimes the material is only for that particular machine. So you can have a different machine, a different material, unless you can play around the process parameter to really produce or understand the raw material behavior. But there is a limitation in terms of raw material, kind of like a ESD material for electronics is not commercially available. But there's a few choice in the market. Material cost, it depends on the machine itself. As for metallic material or for the high performance polymer, the material is quite expensive. And the material properties definitely come with the raw material. Limitation in raw material, definitely material properties. So, and one thing that you need to take care is that the IP intellectual properties issue. Limitation in size is just kind of big because sometimes you can have you can't have the part as one part, and you need to cut it out into a few portions because your machine has the limitation in terms of the size, the building size that it can produce. So different, if a bigger build part, definitely is going to be a very expensive machine. Cost of printers is metallic printers can cost you millions ringgit. Yeah. So that's actually wrapping up my slides, and I would like to also introduce what we developed a few years ago, which is what we call My 3D Printing Malaysia or My 3D Printing Body. So you can actually download these apps in your mobile apps. So you can actually get any design that you want. You can actually get an instant code on how to print, or you can send it to us to print. All at your fingertips. Even if you use Android or iPhone, iOS system, you can download this application to help you probably understand the CAD data and understand how much it will cost you if you want to print something that you want. So with that, I really want to say thank you to Keris team, SMK9, and all the committee to invite me as the speaker for this particular session. Thank you.
Thank you so much, Dr. Isha, for the very informative talk. Okay, para hadirin, our Q&A slot is now open. So please, if you have any questions regarding Dr. Isha's talk just now, do comment it down below. And also attach your social media so we can shout you out.
So I think I saw this question just now that it attracts me so well from Faris Junai. He asked, is it a good choice to create a company that only provides 3D printing service? In your opinion?
It is definitely, it is really, really good because I think the potential is big, and not many people really into 3D printing yet in Malaysia. So you can produce, but you have to look into segment that you want to go in, either the industrial or you want to cater hobbies, because the hobby setup is different. But if you want to cater the industry, definitely require a different set of infrastructure. But it is, the demand for 3D printing has been increased lately. People understand now, and the promotion or the government has played quite an important role to promote the what we call a digital transformation. So with this 3D printing, as I've mentioned, there's a two-part design and manufacturing. You can actually handle it through like the software or application that I mentioned. You can even control the machine, on anywhere that you want. So this is very important as people are looking at to get speed up product to market process. So if you can create within a day, you can go into market quite fast. So please, if you have the chances to get into the 3D printing business, start with the 3D printing service, and then you can actually offer other like machines and materials and a lot of things that you can actually do in terms of 3D printing services.
Yes, exactly. If I'm not mistaken, Dr. Isha also started as someone that was just guiding the process of 3D printing in his early years. And now he's the founder and CEO of 3D Gen. So that's pretty amazing. Also very, okay, so let's find some other questions here in the comment section. Okay, I found one. Let me see. Okay, so here if you can see on the screen, Sir Lear Kuf3, he said, can we forego the needs for engineering? And there's a little sambungan bawah there. I mean, since everything is software based.
We still need engineers in this name because it's not automatically designed or automatically produce the part. They still need a human interference during the process. Definitely now the design requirement require a lot of calculation or consideration before you can actually finalize design. So handling a software is one thing. Handling the machine is also one thing. So the whole process needs a human interference to do, because you have a standard process parameters, but the standard process parameters can be used for a standard part. But once you start to customize it, personalize it into your according to what you want, according to the requirements that you get, definitely it requires engineers to participate in it. So we cannot forego engineers. Engineers going to be still there to manipulate the software and also to handle the machine. But the level of the interference, the level of experience needed, because last time if you want to handle something like TNC machine, to create a two-part is going to be quite difficult. You need to have experienced people there. But with this technology now, digital assumption, now a lot of things have been quite easy. There's a function instead of you draw, you have a function that can drag and drop, put it in. So it makes things life easier with it, but still need the engineers to handle it.
I totally agree. Even with Dr. Ishar teaching us a few skills, even students like us can handle some machines at our level. All right. I think so. This question kind of corresponds with what the past question was. Is 3D printing technology really hard to understand?
No. I think it's quite simple, but you need to at least have sort of a engineering, a technical background, because you need to understand the process, how it builds, the concept of how it builds the thing. Once you understand the concept, like okay, like 3D printing using a layer manufacturing, layer by layer. So you understand if you want to create something, you need to have a layer information. So according to that, then you started when you have a cat, oh, how I'm going to slice it? You need to prepare a slice data. So you know, okay, we need a platform to actually slice the data that you have. So it is not that hard to understand. It is really compared to a CNC machine that you need to program the toolpath and everything. This is kind of done automatically. Once you have a design, you put into a Cura or slicing software, send it to the machine, then the machine will run automatically to your according to your data or CAD files that you have sent. So it's not hard to understand. It just because there's a various type of technology using a similar concept. So like I mentioned that one is using a powder, one uses resin, one uses a filament type. So, but for you to have an early exposure, use a simplest technology like FDM. So that will bring you, expose you to a whole 3D printing workflow, that digital workflow. So when you have that, when you jump into another technology, that will make things easier for you to understand.
Yes, there's a few comments down here in the YouTube comment section that
everyone
that are
is so
suggesting
interested in the topic.
that are suggesting what are the like recommended beginner machines for 3D printing that you would recommend for schools? Yes. Any recommendations for 3D printers, affordable price and user friendly for beginners? By Fauzia binti Muhammad Shah.
Okay, so if you are, like I mentioned, yeah, if you are new to a 3D printing technology, choose FDM printers. That would be probably easy to handle, which is the use of filament, heated nozzles and filament. You can have even now DIY machine. DIY machine costs less than 1,000. A small machine, and you can have a medium range machine which is below than 5,000. That one also can give you a very good part already, with quality part. The only thing is that for DIY machine, there's a lot of things that you need to tweak while you are running the machine. But sometimes the reliability is not there because sometimes they use a cheap component. So one day you print okay, another day you print out. So it depends on but based on the question, if you want to try to understand 3D printing technology, use the FDM machine, which is you can get machine below than 5,000, start to do a design and print using this machine. That would be a good exposure for us to for us to understand the 3D printing process flow itself.
All right. Just wait, yeah. Okay, so we're running short on time, so our Q&A session slot will be closed. Thank you so much for all your questions. Let me just shout out this one comment because I totally agree with it. From Mokhtar Yusuf, congratulations, Dr. Isa. Great sharing new information for students to improve their skills and knowledge. Yes, we totally agree. So thank you so much, Dr. Isa, for your very informative and fun talk. I think so all the audience had fun listening and there was a lot of questions as well. Anyway, let's move on to our next slot with Dr. Muhammad Hussein, or uncle, or bro, pick any of the following.
Professor Madhyar Dr. Muhammad Hussein, upon completing the Masters of Science studying the effect of powder loading and processing conditions of metal injection molding in 2002, continued his studies at the University of Sheffield, United Kingdom, and has since held various positions in the industry. Currently, Dr. Hussein is a senior lecturer at the Faculty of Mechanical Engineering, UITM, from 2002 till this date. And despite being heavily involved with the students of UITM, he has also devoted his time to several F1 in schools and Land Rover 4x4 in school students, such as Synchro 9, Rimau Racing, Valiante 9, and currently Team Keris Racing's mentor.
All right. First of all, I would like to say thank you so much for 172 views. Thank you to every 173, actually, one of you for joining us today. That's amazing. Now, Prof. Hussein today will be talking about innovative thinking. So please, Prof, take it from here. You can start now.
Thank you, Irina and Christina, for the kind introduction. Allow me to share the screen.
Yes. All right. So now that you will be sharing your screen soon, me and Kiss will get out of your hair.
Right. Can you share the screen now? Can you see the screen? All right.
Yes.
I would like to take this great opportunity to thanks to the pengetua, Puan Rosina Ahmad, and also Puan Fazilah from Jabatan Pendidikan Selangor. So it's a great pleasure of mine for having this opportunity sharing through the webinar session. This is a platform where we can share our thought and ideas wherever you are. Okay, thanks to the all these platforms such as YouTube. Right, my name is Muhammad Hussein Ismail from the College of Engineering, University Technology Mara. I've been mentoring F1 in school since 2016. Started with the Synchro 9 in 2016. So this is a bit about my presentation layout, a bit about my background, research and innovation. MHI stands for my name. MHI Innovation Project, mainly on the ways to wealth, STEM education, why innovation matters, ideas of innovation, and lastly, the concluding remarks. So this is a bit about my research innovation. So it's a bit complicated. It is about producing dental implant by metal injection molding. Previously, Dr. Izhar highlighted in detail about the technology of the 3D printing. And this is another technology, in my case, metal injection molding, using a very fine metal powders to produce the small parts. So in this case, we can produce mass productions of the components. So basically, in 3D, a dental implant consists of, if you look to the this figure, the dental crown, and then this is the system for the dental screw, which comprise of these three main components. So our innovation is actually want to highlight on the local manufacturing, and then hopefully we can market this product by year 2022. So this is a bit about the how the dental screw looks like under the high magnification microscope. So basically this project started since my PhD work somewhere in 2007, and then we continued for the research and development to see the potential for the not only for the dental implant but also for the other types of the implant. And we're also looking for the non-biomedical application owing to the unique properties of these materials. So whenever we talk about the innovations, okay, the first question that need to be asked is some of the problem statement. So when we start the innovation, the most important question is the problem statement. So why we come up with the porous structures? Okay, one of the critical issues in many implant is mismatch of the young modulus. Young modulus is a characteristic or the properties of the metal, which is characterized through the mechanical testing. So basically, metal can be divided into many types. Okay, for example, mainly used for the dental, for the implants such as titanium alloy, stainless steel, bulk nickel titanium. Okay, the one that Dr. Izhar mentioned just now for the implant, mainly titanium alloy. Okay, one of the important properties of the titanium is the modulus Young, or sometimes it is called modulus of elasticity. Okay, which is classified as 110 gigapascal, stainless steel 210 gigapascal, and the bulk nickel deuterium is 48 gigapascal. When we compare with the hard tissue, it is about less than 20 gigapascal. So when we compare between the implant material and the hard tissue, it has a huge difference. Owing to the huge difference between the implant, mainly dense structure, with the bone, it will give a negative effect, which is called stress shielding. Which is reduction in the bone density as a result of the removal of normal stress. So this figure shows the problem if we have a dense implant in our body. So you can see here the region here, which is due to the mismatch of the Young modulus between the implant and this one is the bone. You can see here the colors representing the stress shielding, owing to the difference of the modulus Young. And beside that, I also done a lot on the innovations of waste to wealth project. Okay, from plastic and waste bottles, producing a plastic product, aluminum can for the souvenirs. We produce these very simple furnace purposely for educations, particularly when we have exhibition at school. So we bring this furnace at school and we demonstrate the concept of the melting. And then incinerator bottom ash, this is the project that I did before I went for my PhD. Sludge paper ash, producing brick and artificial aggregate, clamshell. One master student completed doing this for the bone substitution, eggshell, bone substitution, empty fruit bunch, ash brick, and then for the soda. So these are some of the product, and some of the outcome of the project was published in technical paper publication. Right, innovation. When we talk about innovation, the title is innovative thinking. Why it matters? Okay, it is driven by the ability to see connection. Okay, when you see the opportunities, okay, you spot the opportunities and take advantage of them. Then how you blend the information to come up with the new innovation. So it is not just about opening a new market. It can also offer a new ways of serving established ones. And innovation is not only manufactured product. Okay, it also can process innovation. So these are some of the example. Okay, the one that we are having right now through the YouTube. Before this, through the physical. So normally we have to arrange at the big hall, and then we have to invite speakers. We have to ensure the participant. But now, as long as you have the internet access, as long as you have this platform, either Google Meet, YouTube, Zoom, or WebEx meeting, you can arrange meeting everywhere. Okay, and in terms of getting foods, okay, so you can have Food Panda and you have Grab. Before this, okay, you have to go to the restaurant, okay, buy foods and then take it home, right? So these are some of the examples of the technology that we use for due to the innovations. Okay, so innovation is the symbiosis between creative organizations. So if you look to the cycles of innovation, starting from the ideas, you define it, and then you have to test it to make it whether the idea is suitable to be proceed, and what are the things to be improved, and then come up with the design it, and then you have to brand it. And if they say that the ideas or the innovation have the good opportunity to be market, then you have to make sure that you secure your IP. It is very important because it is important to protect your ideas. If not, somebody will steal your ideas and claim that that is them. Okay, so these are basically the ecosystem of the innovation. When you have the idea, and then you have to produce, whether it's a process or product innovation, and then you have to brand it. Okay, and then you have to make sure that to protect your ideas. So this is basically the product development. It is some symbiosis between the creative organization and creative people. To have to be innovative, you have to be creative to produce the innovation. So it is interplay between the individual creativity and environmental creativity. Is you are creative, but the environment doesn't give you the creativity to embark. So it will be difficult for the innovation to be developed. And that is a driving force of the innovation in an organization. At school, the way the teachers educate the students, it also a part of the innovation. Okay, the teachers will come up with the new ideas of teaching, come up with the new approach using the apps, using the any platform, okay, to make sure that the student always engage during the class. So this is a bit about the evolutions of some of the technology. Okay, the first example is the way how we store the uh, data. Okay, from the 8-inch floppy disk. Okay, I believe that maybe some of you never experienced using the DVD or floppy disk. Okay, maybe some of you have know about the USB, SD card, and now the cloud computing. As long as you have the internet access, the data that you save through the Google Drive, then you can access all the data. Okay, anywhere. Okay, as long as you have the internet access. Okay, long time ago. Okay, during my study, I have to use the floppy disk in order to store the data. Okay, and then about the cell phone, these are the evolution of the cell phone from the bigger size. Now we can have a several function with our smartphone. Not only for the text and also have a call, but the smartphone can be used in many things. You can do a online banking. You can watch movie. Everything. Okay, use your smartphone. So this is our innovation lab at UITM. So at UITM, for this innovation lab, we are mainly focusing on the ideation towards 3D printing technology. It was officially launched in September 2019. Okay, and these are some of the activities potential through the ideations, and then producing prototype using the 3D printing, and also other manufacturing techniques. Okay, and we identify the potential collaborators. Okay, so 3D Gen is one of our collaborators, mainly for the additive manufacturing for metallic materials. So these are some of the activities in our innovation lab. Okay, we're organizing the event, and we have so this figure show the student of Valiante 9, okay, with the former F1 in school, Mr. Nasri. It was 2 years ago. Okay, and then this the person from the Fraunhofer IEM. This lab is actually a collaboration with the Fraunhofer IEM from Germany. And these are some of the innovation from the staff. Okay, so the example of the 3D printed project. It is project by FTTC, drone by Dr. Rizal. Okay, produced by manufactured by 3D printing in our lab. And this another activities led by Dr. Halim and Dr. Ayuni. Okay, helping the disabled kids at Terengganu. So they produce this kind of the 3D printed components. Okay, to facilitate the students um, for the daily activities. And this is another project done by our staff on the robot. Okay, so innovation in robotics. Okay, led by Dr. Hanafia, which is the CEO of the Robopreneur. There's another technology on the rocket propulsion, okay, for the cloud seeding in collaboration with the company MTC Engineering. So all of this about the innovation, whether the innovation is small level or higher level, it need certain level of skills, especially to grab the ideas and then how they want to execute your ideas toward better innovations. Right. So when we talk about innovation, it's very related with the STEM. Okay, what is STEM? STEM stands for the science, technology, engineering, and mathematics. Okay, so these are some of the figures showing how we empowering the STEM education. Okay, through the STEM carnival, we do the exhibitions either at UITM or outside UITM, or sometimes with the industries. So this figure show the Valentine 9 at the 3D Giant premise. Okay, so this figure show the to expose to the students on the concept of the gravity car. Okay, so these are some of the importance of the STEM. Okay, currently the ratio of the student who are taking STEM, particularly after Form 3, declining, okay, from year to year. Okay, this may be because of the awareness about the STEM. So as lecturers, as educators at universities, we should take a role to give some awareness, okay, particularly for the students, okay, the importance of STEM through this event. Okay. Right. When we talk about innovation, why it matters is because now we are uh, in the new era of IR 4.0. Okay. So one of the main attributes of the IR 4.0 is 3D printing and other technology related, such as AR, VR, space technology, artificial intelligence. So as a students of now you are going to the university, for example, you have to know with this technology. Okay, for example, 3D printing. What do you know about 3D printing? What are the capability of the 3D printing? Okay, for the ideas of innovations, and there are other aspects as well. Okay, so these are the jobs and the threats. Okay, for example, travel agent. Now, before this, we need travel agent to go anywhere. Okay, but now you can just Google. Okay, you just go to any website to travel overseas. Just go to the website. Okay, tellers, surveyors, journalists, legal assistant, finance assistant. So now, if you look to the job that did not exist in 20 years ago, such as bloggers, sustainability managers, drone operator. Now we have quite numbers of new industries working on the drone operators. Apps developer is one of the job that have a good opportunity in the futures. Okay, social media strategies and data scientists. So when we talk about this, the job, it is about the use of technology, the IT. Okay, if you're mastering in IT or mastering in technology, that will give values on top of your degree or your SPM. So for the SPM, this will be a value add if you want to choose the right program in the degree level. And for the degree students, of course, this will be a value add, okay, on top of your degree. Okay. So these are just want to give you some ideas how the STEM education can be embedded with the some innovations. Okay, so these some ideas. I believe that maybe some of you familiar with this during my age. Okay, when I was kid, this is one of the card game that I used play with my friends. Okay, this we call it top trump. Okay, so actually, the idea of this concept is actually want to give you some insight on the how we can educate student in the other platform where uh, in the fun way they decide that we can give some information related to the topics. So in this case, I translate the topics of material, okay, in the form of card game so that the student can understand some of the important properties such as, for example, metal, aluminium, metal. What are the important properties? Okay, through these card games. Okay, so these are the card game which was by the students of SMK Section 9, where I mentored the students, and they participate in the innovation competition last 2 years, and they got a bronze award for this innovation. So it's not really complicated, just to compare all the data of the material and then turn it into card games. Okay, so I believe that maybe some of you very familiar with this. Okay, periodic table ataupun jadual berkala. Okay, so we have lots of element here. Okay, and then I just want to focus here is about the metallic materials. Okay, for example, this ferrum. Okay, ferrum or iron. Okay, so it is a main elements in steel. Okay, for example, our fork and spoon are made of ferrum. Okay, so these are some of the important properties for this particular metal, such as melting temperature 1563 degrees Celsius, then the density of 7.86 gram per cubic centimeter. And the second types of the metal is aluminium. Okay, when we talk about the aluminium, okay, about melting temperature, it's about 660 degrees Celsius, and the density about 2.69. That's why aluminium mainly used for the body frame of the bicycle, okay, because these properties of lightweight properties. Okay, 2.69 compared to the ferrum base is about 3 times greater than the aluminum. Then this is another example of titanium that mainly used for the biomedical application, owing to unique properties of moderate density as well as unique mechanical properties. Right, this is titanium, right? And there are other type of metals that can be found in the periodic table. And then we turn it into another card, okay, which is mainly for the metals. Okay, so these are some of the properties, okay, of the metals such as density, melting point. Okay, so when we combine all these metal, we have more than 20 types of metal. So the way we play the game almost similar with the one that we use for the top trump game. So we can educate the student not only to understand the type of the metal, but to understand the some of the important properties for that particular metals. And beside that, we have also CSR activities. Okay, this was 4 years ago at school SMK Section 9. Okay, we promoting not only STEM but incorporating the A, which is art. Okay, so what are the element of arts here? We produce some sort like product which is from the waste material. Okay, so these are the furnace that we produce from the final year project student, and then this student demonstrate to the school students on the concept of the melting using the aluminium, okay, aluminium cans, and then the temperature is about 660 degrees Celsius because the temperature is not too high. Then the sample easily melt, and then we can produce a simple product as for the demonstrate to the student the concept of the melting and also a casting process. So this is another innovation about the plastic. Okay, did you know 100% of plastic can be recycled? So there are lots of these are one of the big issues, not only in Malaysia, but it is a global issues. Okay, plastic everywhere, and then not many countries really practicing recycling activities. Okay, 100%. And then these are some of the facts and figures. We aware about the waste recycle. We practice it. Okay, so if compare between our countries, okay, Germany have practicing about 66% of recycling activities. Our neighbors, Singapore, about 57%. In Malaysia, only 11%. Okay, do the recycle activities. So these are some of the issues. These are some of the issues. Even though that we have a separate bin, but the issues is, yeah, like this. Okay, we put everything, okay, not on the dedicated bin. Okay, for example, this one for the glass, but you can see what's the trash here. Okay, and then let's have a look, just to show you the some of the example, okay, how we can do the innovation from these issues, okay, the big issues of the plastic waste. Okay, for example, here this one can be found on the food container, and this one the detergent bottle container. You can see the numbers here, right? So these are the issues. Okay, how long does the plastic take to break down? Okay, for example, the soda bottle or the mineral bottle or PET, it takes about 450 to 1,000 years to be decomposed. And the plastic bags, about 10 to 100 years, HDPE. The detergent bottle, it takes about 500 to 1,000 years. So these are the global issues. So if we don't start at home, separated the plastic and other types of the waste, okay, it will give impact uh, uh, to the garbage collector and need more things to do in the next process. Okay, so did you know this number? Okay, did you know these numbers? Number one, number two, number three. Many people give a wrong answers for these numbers. Okay, basically this indicates the different type of the polymer, which is PET, HDPE, LDPE, polypropylene, polystyrene, and others. Okay, so number two doesn't mean is not reflecting how many times it can be recycled. It actually reflecting the material for that particular polymers, right? And these numbers were developed by the Society of Plastic Industry (SPI) in 1988. Okay, it is called Resin Identification Code. Okay, Resin Identification Code (RIC). So we have different categories. Okay, So the number one is PET for the mineral bottle, and then we have HDPE, high density polyethylene, vinyl, PVC, and many more. Then there are some activities to as a part of the awareness, recycling, and also upcycling. What is the main difference between the recycling and upcycling? So basically, the main issue is still the same. Okay, conserve the environment, reform a product into a material. Okay, but the for the upcycling, the final product have a better quality. It has design unique, handmade, and limited edition. So basically, this is the main difference between the recycling and the upcycling. So in order to understand the way how to recycle this material, we need some information. It is not everything we can do recycle without the basic information. So in this case, the most important thing is, and it, with regard to the manufacturing, with the polymer, different polymer that we use, because it is subjected to temperatures, and then we have to know what is the temperature for that particular plastic of that particular materials. So in this case, we tested two different polymers. The first one is the three polymers, HDPE, PP, and PET. You can see the different temperatures, indicating the different melting temperatures. For example, the HDPE melting about 134.15 degrees Celsius, polypropylene about 164.95 degrees Celsius. So it means that whenever you want to recycle, you have to melt this particular material at this particular temperature. So for the PE, you have to melt at least 135 degrees Celsius to ensure that it completely liquid and it can be shaped to other components, right? So these are the ideas of plastic making. Sometimes we have to think out of the box. Okay, some of the concept that we see every day. These are the example of the wafer maker, right? So the concept of the wafer maker, they apply heat and then they apply pressure. Okay, so these are the some of the example of the product that is manufactured from the waste plastic, okay, using different methods. So in the engineering faculty, we have a machine, we call it hot press machine, where we can apply heat simultaneously with the pressure, and then to produce parts. Okay, then another thing is how do you want to blend some of the info. So this is the project done by my final year project. Okay, so this is about the Islamic calligraphy. Okay, and then this is the history of Kufi script. Okay, how do you want what do I want to blind with the recycle activities? So basically, these are very good info to give some insight on the some of the arts that can be translated to make it into something that is very unique. Okay, so these are to give you some ideas. Okay, what do you get the idea from this Kufi? Okay, actually you translate it into the word here, hot Kufi. Okay, actually this one is the word mechanical, mim ya. So from here to the center. Okay, mim ya kap lam. So the word mechanical. And then from here, we produce the very simple mold pattern, consists of these three components. And then we apply the same concept. We heat it up at the temperatures of
Hi, Prof. Sorry
yep,
to disturb your slot. I just wanted
yep,
to remind you that we have 5 minutes until the Q&A slot.
okay, right,
But
no worries.
please do
Okay,
continue.
yep. Okay, this is an example of the product we produce from the polypropylene and polyethylene. And these are some of the souvenirs, okay, uh, from the recycling plastic. Okay, I believe that many of you are familiar with this Lego and the Tupperware. So this is another example of the manufacturing that we produce by the plastic. Okay, the first one is the plastic injection. Both are using by plastic injection molding. Okay, so these are the injection molding. These are some of the components that can be manufactured by injection molding. Okay, so the same Kufi calligraphy translated into injection molding. We produce a mold. So before we produce a mold, we have to do simulation in terms of the locations of the gating. Okay, to get the right proper flow of the plastic during the injection, and we produce the mold. And then this is the example of the product where this one is from the lubricating oil bottle, okay, which is gold color, and then this one from the shampoo bottle. Okay, these are some of the product produced by my final project students. Okay, And this is a big machine, okay, for the industrial scale. Okay, so this is another product where we produce the trays. This bring the as a souvenirs for the participant during our activities somewhere in 2015, and as souvenirs in other activities. And they also the craze was used as a souvenirs for the Team Aero craze in Singapore 2018. Okay, it's out here, right? This is another example how we solve the issues of the broken chairs at our faculties. There are so many broken plastic chairs at our faculties. So we turn it these ways into another product, which is a card holder. So for the plastic chair, it is a polypropylene number 5, and then we crush it, and then we got more than 1,000 pieces of this card holder. For example, this one, the green color, the brown color is from the plastic chairs. This one from the detergent bottle, the white one from the detergent bottle, and also this the green colors. So before we perform the injection molding, it is very important as engineers to do the simulation to simulate the behavior of the flow, so that we can get the right information on the parameters that we use during the actual injection molding. So these are some our achievement last 2018. Okay, and beside that, we produced 2,000 pieces to the Asasi UITM. Okay, we make profit from the our mass production of our card holder. And these are the another concept of innovation instead of 3R, which is reuse, reduce, and recycle. Some of the awareness campaign activities applying the 7R, which is rethink, refuse, repurpose, and ROT. Okay, so these are some of the activities and our faculties, some recycle awareness inside and also outside UITM. And this one, the impact of recycling awareness. After this, Ishra will be explaining in detail about the how the innovations of this recycling of the bottle cap, which is one of the plastic material that apply for the one of the innovative ideas for the F1 in school. So these are another project done by the lecturers of plastic waste and recycle potential. Okay, making the interlocking brick, and then these are for the possible of the waste for the construction materials. And then about the 3D printing, because the 3D printing, they produce waste structures, so it is possible for this particular component to be recycled. So this bench top, okay, you can see that here is a notebook. We have the design, and then the part is 3D printed using the commercial FDM 3D printers, and then there are some structures part here, the support structures, and the support structure um, can be recycled, okay, using this machine extruded and producing the filament, and then this filament will be inserted to this machine, okay, for the next 3D printing process. Okay, so the material can be PLA or ABS. So these are the ecosystem of the 3D printing by using the FDM. And then about the PLA, okay, these are the uniqueness of the PLA, where it can be decomposed by day 80, okay. And then these are some of the innovation. So we do the characterization of the waste material, this one from the support structures, and then we compare the properties between the waste filament and also with the virgin element, and we test it mechanically, and then we compare with the virgin material, okay. And also for my last presentation is about the innovation during the pandemic COVID last year, where we started with the 3D printing and design of the face shield. Okay, we started with the 3D printing, and because of the processing of the face is time consuming, and then we shift to the injection molding. So these are the first phase where we produce by 3D printing. We have a very limited numbers of face shield produced. And then for the second phase, our staff in UITM Mechanical Engineering, we print at every residential locations. And then for the third phase, we produce in mass. Okay, and then these are the CNC injection molding. we managed to produce about 42,000 pieces of face shield all around Malaysia. These are some of the delivery locations. So as a conclusion, okay, so creative mindset is very important tools in innovation. It will lead to new product and processes that sustain our economy. Okay, and technology and IT play important role in innovation to create value creation not only for the student, for the organization as well. And STEM education create critical thinkers, increase science literacy, okay, and enable the next generation of innovators. So for that, yeah, thank you very much.
All right. Thank you so much, Prof, for your slot just now. It was very informative. Now we can officially open our Q&A slot. So, jadi para hadirin, can you please comment down below any questions that you have for Prof Hussein, and we'll pin it to the screen.
So we have the first question here from Masrina. She asks, can we recycle plastic even when we didn't have those things?
Pardon?
Can we recycle those plastics even when we
Yeah.
didn't have things?
We can start with the 3R. For example, reuse or reduce. Actually, I got some of the concept of the recycle using the our conventional oven that we have normally at home. So because the oven can set up at the temperature of maximum about 300 degrees Celsius. So for example, if let's say that you want to melt the plastic like a polyethylene, the melting temperature is about 110 degrees Celsius. So we can make a very simple innovation, melt it at the oven. But this oven, we cannot mix with with the foods. Okay, if let's say the oven is used for the plastic, then we have to separate with for the food purposes. Okay, and then we have to think about the approach how we can press the softened material, softened plastic, and then turn it into products. So there's the simple machine that we can apply at home.
All right. So the next question here is from Aisha Idris. She says, wondering some plastic waste is dirty. When
Yeah.
we collect them up, by washing them or cleaning them, will the cleaning process change the behavior of the material? That's a good question.
Yeah, it's not really. Actually, the detergent, the cleaning detergent only move away the dirt, okay, from the plastic. For example, plastic food container. Okay, so normally we use detergent to remove the stain on the plastic container. Then actually it doesn't affect significantly the properties, particularly on the melting temperatures and other properties.
Right.
Yeah.
Another one on the screen here, it says, this is from Chika. Could you recommend some plastic recycling sites in Selangor?
In Selangor, actually, we have the recycling center. I'm not really sure the recycling center whether it's working or not. Somewhere location at the Pasar Section 6. Pasar Section 6, they have a recycling center there. But for the recycling, meaning that through the process, for example, the use of the hot press, injection molding, um, some universities have this machine. So in Shah Alam, in UiTM, in our faculty, beside our faculty, other faculty also have this unit, namely a faculty of applied science and also faculty of chemical engineering. Okay, this one is referring to the machine, okay, machine of injection molding. Okay, if let's say that you want to go to the recycling center, then you can get your money. Okay, you can bring your plastic or other recycled items there.
All right, another question we have here on the screen. What's the difference between recycling and upcycling by Aisha Idris once again?
The one that I share, through the slide here, the difference between upcycling and also the recycling. Basically, from the beginning, the process is not much different, but the way we manufacture it or the way we produce it will be slightly different. Okay. Let me go to the difference of the, where is it? Okay, this one. Right. So for the upcycling, we produce a better quality. For example, if we have the plastic, okay, the way we do the recycling is we just transform this plastic waste into the product. Okay, we use 100% of the plastic. But for this one, okay, for example, for the upcycling, we we convert this plastic into another product. Okay, for example, like this one, okay, product are repurposed and refashion into something useful, okay, such as the bags, okay, this one, okay. But for the recycling, require process to break down the original material. So the one that I did in innovation that I presented just now is all the process of recycling, and this material can be recycled, okay, depending on the severity of the materials, and as long as the material can be recycled and it can be processed using the same approach, for example, injection molding. Any other questions?
All right, so here's the last question of the day for Prof. Hussein's slot. Are there any negative effects of recycling from Sharvin?
Negative effect, of course. The negative effect is on the processing, because sometimes we apply depending on the way how we manufacture, how do we recycle it. Okay, there are some other cases that they heat it up at high temperatures to produce oil. Okay, so these are some other researchers from other institutions. They heat it up to more than greater than 500 degrees Celsius. So the concern is the vapor. Okay, the concern is the vapor that the byproduct from the burning the waste at the high temperatures. So in terms of the recycling process, it doesn't give any significant implication to the environment, because we use the same machine as what we use for the industrial machine. Even in some of the industrial injection molding, they also use some portion of the recycle in order to conserve the material and also to conserve the environment. It depends. It depends on the processing method that we use. Okay, for the different purposes. Right. Hello.
Erina, you're muted.
I need to stop doing that. I'm sorry. Anyway, thank you so much, everyone who commented down below all your questions that you had for Prof. Hussein, and also for staying focused throughout his talk. It was very informative. Thank you again, Prof. Hussein, for giving such a very informative talk. That was very fun for the students and for the team as well. So thank you so much. Now let's move on to our last slot of the day. Please.
Alright, now for our last slot of the day, we have Mr. Wan, a former student of SMK Section 9 Shah Alam, class of 2019, who has also participated in this prestigious F1 in Schools competition, competing in the regional and level all the way up to the international level as the design engineer for Synchro 9, whom won the F1 and School World Finals 2017 Best Innovative Thinking Award, and is currently pursuing his foundation in engineering at UiTM Puncak Alam.
Wow, that's 3 years worth of experience in F1 in schools. So definitely beats us, Keris. This is only our second year. So please, Mr. Wan, take the stage. It's yours.
Okay, Assalamualaikum and good morning to everyone. I think I want to begin first with acknowledging Keris Racing's professionalism, and all the things they've done. This is actually really impressive for me. I don't think I would have done this back when I was in school. And throughout the entire process, they've been doing an extremely good job. And thank you to Dr. Hussein, thank you to SMK Section 9 for this opportunity. So I'd like to begin with some background about the things I've done. As Arina said, as Keris Racing has presented us now, I was part of F1 in schools from the years 2017 all the way to 2019. So because of that, I think I have a lot of experiences that most people my age didn't get at the time. So these are my objectives for today. It's nice to have a clear outline of what we're going to do. And I just want to share my experiences during my time in F1, give some insight about what innovative thinking the award is about and the innovation that helped us win it. I want to talk about our collaboration with UiTM because that was a very important part of F1 in schools for me. And lastly, I want to demonstrate how a lot of innovation comes from collaboration. So, as you all know, I was part of Synchro 9 and I won the Innovative Thinking Award during the F1 World Finals in 2017. So, the criteria for actually winning this award is that the idea has to be original. It has to be an innovation that is related to the project itself. So, in F1 in schools, you have this competition where you have to raise money, you have to design a car, and you have to manufacture the car. So there's a lot of aspects to this competition, and any innovation in any aspect is considered for the Innovative Thinking Award. See, back during my time in 2017, a lot of F1 schools team focused their innovation on the car. They focused it on, the basic things that if you hear F1, that's what you think of. That's what they focused their innovation on. The thing that made us unique was that we didn't just focus on the car, we didn't just focus on the project, but we focused on social issues. So the social issue that we focused on was recycling. It was about the environment. So it was this innovation that was unique because we marketed our team while also promoting the importance of the environment. And it helped a lot because environment is something everyone should be aware of. I know if you were born around my generation, around 2002, you probably grew up listening about recycling, about how important the environment is. Every few years or so, there's going to be a new movement to spread awareness. And the reason why it hasn't worked so far is because people keep forgetting. It's human nature to forget. And because of that, it's actually very important that we do remind people, we do spread awareness, even though we might ourselves might forget. So this is our innovation. Our innovation was a sync chain. In collaboration with ITM, what we did was we had this marketing campaign where we promoted the importance of recycling and we asked students from SMK Section 9 to participate by sending in bottle caps. Now, not a lot of people know this, but bottle caps are actually really hard to recycle because most of the time when people recycle these bottle caps, they don't just open the bottle cap from the bottle. They actually just screw in the bottle cap with the bottle and just throw it into the recycling bin. And the thing that makes that difficult is because it takes effort to remove the bottle cap. It's when you're processing for recycling, you're dealing with thousands of these recycled materials, and if the bottle cap is still intact with the bottle, it makes it hard to separate them. Someone has to separate them, and because of that, it costs money. And once it costs money like that, it starts becoming uh, unsustainable from an economic standpoint because what happens is that you're spending money to do something that that is not really contributing to recycling overall because yes you can recycle the bottle caps, yes you can recycle the bottle itself, but then if you have to separate them it costs more money than if you were just to recycle each separately. I think there was a few campaigns back earlier that asked people to separate the bottle caps, but again, people forget. So, which is why we did this campaign so that people were aware of why we need to separate the bottle caps. And as Dr. Hussein said, there's several codes at the back behind these bottle caps. For example, the code 4, which represents the material of low density polyethylene, and the code 2, which represents the high density polyethylene. So these were the two main plastics we were working with in F1 during our time in F1 schools. So as you can see here, we took these bottle caps and we turned them into these keychains. And this was a very effective way of helping people remember about the importance of recycling. So everyone will have these keychains and they would be aware of what they did to help the environment. And it's also important to note that when it comes to things about climate change or the environment, one of the reasons people don't really do anything about it is because sometimes it feels impossible. A lot of people think that even if they tried, they wouldn't make a difference. And that's the big problem. See, it takes everyone should just take one small step, and together will make a big difference. As long as everyone takes that small step. And there's a proverb in Malay which says sedikit-sedikit lama-lama menjadi bukit. And that really applies when it comes to social issues like this. As Doctor says, Malaysia only recycles only like 11%, and that's a big issue because we're way behind from modern countries. Right. So now this is a video we need to do for the marketing. I hope you guys enjoy.
Sorry, Mr. Wan, but there's no voice, no audio
Okay.
attached to the video.
So this is basically the process of recycling the bottle caps that we did with UITM. This is an injection molding machine where we would take the plastics, we would crush them first, and then the pellets will be put inside this machine. Then it will be heated up, and the plastic will go into the mold and turn into these keychains. Right. So this was the innovation that we did with UITM. The innovation of creating something out of bottle caps, the keychain, which spread awareness and it helped people uh, engage with the environment, engage with Synchro9, and help promote our team. So there's a lot of benefits that made this the winner of the Innovative Thinking Award. First of all, as I said before, the Innovative Thinking Award doesn't it needs to be innovation, but also has to be effective at what it does. And the reason we created this sync chain was so that people were aware of the environment and they were also aware of synchronized effort in F1 schools and also helping the society around us. And this is I've been reading this book. It's called The Future We Choose, and this book was written by the people who helped design the Paris Climate Change Agreement. And if none of you know, the Paris Climate Agreement was this international collaboration among several big countries where they all agreed that they have to take steps into fixing the environment, into controlling the increase in temperature. And it was an extremely big deal at the time because this was a huge international collaboration. Every country has their own needs, their own wants, their own goals, but for us as humanity to come together and work on this, that is something that we should be really proud of. After all, this innovation was also a collaboration with Dr. Hussein and UITM, and because of that, I think one of the important things people need to remember about innovation is that it doesn't just come out of the blue. You don't just suddenly get, oh, I got this unique idea, it's going to change the world. A lot of innovation actually comes from collaborating with other people, sharing ideas, talking about it, discussing. And when you discuss with other people, you get a new point of view to what your idea is. And that's how a lot of innovations has happened throughout history. And like I said, the collaboration we had with UITM was extremely beneficial. We as Synchro9 knew we had to do something. We need to innovate because social issues were extremely important, and we have this platform to help people. Back then, during Synchro9, I think a lot of people were like, "Oh, we should promote STEM." Yeah, yes, STEM is important, but then what about other issues like the environment? And we were thinking for a long time on how to solve this, which is why when we were starting to discuss with Dr. Hussein about our problems, we suddenly discovered that we could do this innovation because Dr. Hussein was explaining about injection molding, and we were thinking, hey, we actually can do a recycling campaign and we can create these keychains using the injection molding. So this was one of the results of the collaboration we had with UITM, and it benefited us a lot once again. And as you can see here, here's the process for the innovation for creating this keychain. So what you would do is that you would start with these waste bottles. So in school, we would collect these bottle caps from everyone. We'll just find people who want to contribute. So instead of throwing it into the trash can, we would ask people to give these bottle caps to us directly. Then we go through a process that is known as pelleting. So pelleting is when we take these bottle caps and then we would crush them. We crush them into very fine, tiny pieces like the ones you see here. And after we have all these pellets, we would then prepare a mold. So this mold uh, was actually with the cooperation of Dr. Hussein. He helped us make this mold. See, this is our logo, the Synchronine design. And we talked to Dr. Hussein and he managed to help us create this mold. So with this mold, we can start producing these keychains by melting the pellets that we have before. And as Dr. Hussein mentioned before, we use the injection molding. This injection molding is actually quite high temperature. I remember wearing gloves during the process, and it was actually a very unique experience you won't get in school. So after we have this injection molding, then we have finishing, and finishing is basically when we start, polishing the keychain, making sure it looks good. Because again, this was a marketing campaign. We wanted people to be aware of the environment and see the effects of recycling firsthand. So when they see these keychains, they will be thinking, "Oh, wow, we actually made a difference in the world. We actually, our trash actually turned into gold," and it was again effective. So moving on, I just want to talk about the collaborations we have with UITM. So besides the keychains that we made with UITM, they also helped us with a lot of the other aspects in F1 schools. Because we're school students, there's a lot of things we don't know, and a lot of things that we do learn cannot necessarily be applied to F1 in schools. For example, in physics, I think you learn about one-dimensional motion. Well, in F1, you actually have to learn about at least two-dimensional motion, something you would learn in university or Asasi. So we had to find the knowledge, and UITM helped us with that. They gave us insight into the basic processes and principles of engineering that helped us design the car. They discussed with us about the physics, the concepts, and the principles that helped us understand more about how we can design the fastest car. And lastly, they gave us tutorials on how to design the car using programs such as Autodesk Inventor, SolidWorks, and softwares for analysis like SolidWorks and a few other software that helped us understand the fluid dynamics of the car. So moving on, I also want to talk about the innovations that happen from collaboration. As I mentioned before, a lot of innovations throughout history has been because of collaboration. And the two most important ones, in my opinion, was the internet and the plane known as the Concorde. So the internet actually started off as a government project. It was called ARPANET in the USA, and it was done by the Advanced Research Projects Agency, which was under the Defense Department. So what they were doing at the time was they're trying to create this communication network for the military. So they wanted to share secret information and they wanted to share that instantly and without any troubles. But then eventually, as time went on, different universities and organizations started their own networks. And as time went on, these networks began being combined. So there's innovations in different types of protocols and networking, and they would connect all these networks to form the internet, and that's what we know today. And this is a very important example of innovation that came from the collaboration of different organizations. Universities, government agencies, companies, all of them have different needs and different goals. And they all collaborated to produce this innovation that wouldn't have been possible without cooperation and teamwork. And the internet is actually something extremely special because it allows us to share ideas and discuss with people from all around the world without any limitation. So just like what we're doing now, me sharing my experiences, the internet has led to an increase in innovation overall. Uh, you can see this a lot with all the technologies we have today, like 3D printing and all the types of design technologies, all the electric cars, because people who have information, who have knowledge about these things, will eventually have their own ideas. And when they contribute those ideas, that's how innovation is formed. I also want to talk about the Concorde. See, the Concorde was actually the first supersonic plane in the world, a plane that can go faster than the speed of sound. And this was a result of a collaboration between British and French companies. See, the British tried to do it on their own, but then the French realized that they also wanted a plane that was capable of going supersonic and carrying passengers. So when they started working together, a lot of the innovations can be found, from the airframe to the engines to the design of the plane itself. And this was an example of international collaboration between two different countries, which is a lot harder than it sounds. In my experience during F1 schools, I did collaborate with a few universities outside of Malaysia. I collaborated with Dr. Roger from UCLA, and it was extremely hard for me to collaborate and cooperate with him because there's so much distance. But then it provided me insight that I wouldn't have gotten here in Malaysia. It gave me knowledge that I wouldn't have even thought of. It showed me things that wouldn't be possible if I just stay in school and discover things there. So I'd just like to highlight the fact that it's very important when you want a new unique idea or when you want to solve a problem to discuss with other people, to brainstorm, to talk about your ideas, because when you talk about your ideas, it invites people to talk about theirs. And when you start mixing the ideas together, it becomes something new and unique. It becomes something innovative. And I think that's the main goal of my presentation actually for today, is to make people realize that collaboration truly is one of the main factors for innovation. Now I actually want to go into some of the processes that we went through in F1 schools. First of all, this is what we call the design process. This is something that UITM taught me, and it starts with benchmarking. So benchmarking is basically when you start analyzing your past mistakes, analyzing your past designs, and figuring out what went wrong. And when you know what goes wrong, then you have a problem. And now you have to start researching to find solutions to that problem. So there's a lot of research that goes on actually during F1 schools. We had to look into a lot of inspiration from the nature, from the machinery, devices around us in order to solve our problems. And once we have all these ideas, we start going to the CAD or computer aided design. So we would take the ideas we have and design it into a car. So we would start with different components, and then we'll combine them together, and then we'll run them through analysis. So in this analysis, we start checking if what we've done actually solved our problem. So if our ideas was actually effective. And throughout my time in F1 schools, I think a lot of my ideas actually didn't solve the problems. It actually made more problems, which is why analysis is extremely important in the process. A lot of people tend to skip analysis. They think, oh, okay, I have a design, it's probably going to work, but that's a really bad idea. Every time you have an idea, you have to test it, because if you don't test it, it's not really a good idea. Then you might be guessing, you might be wrong, and when you're wrong in engineering, it results in catastrophic failures, and it becomes a big deal. Even the smallest mistake can cause big problems. So once we've done the analysis, we would verify and validate. And again, we would check if it actually solved the problems, if the ideas solve the problems that we found during benchmarking. And if it's not, then we'll go back all the way to the design process, to the modeling process, to see what we can do differently. And after all of that is done, and we finally solve the problems that we were trying to fix in the first place, we would have our final design. And these are some of the tools and design skills that we got during our time in UITM. So as I mentioned before, this is CAD, or computer aided design. We would be using Autodesk Inventor to design our car. So as you can see here, this is me designing our car We have different tools that we use. We used a tool called Fillet to smoothen out edges. We used a tool called lofting to create this loft from different 2D sketches. Then we have something called CAE, which is Computer Aided Engineering. And this is basically when we start doing our analysis. So as you can see here, this very bright colored picture, this is actually what we call a virtual wind tunnel. So we would run this on a 2D scale to examine the flow of air over the car when as it moves through the air. So as you can see here, you see all this swirling at the back here. That's what we call a wake region or a vacuum. So all this air will be stuck, being pulled into this area, and that will cause drag. So that's one of the things we had to examine during our time in F1 schools. You can also see the bottom picture here, the one with the blue and red gradients. So this is what we call a air pressure analysis. So we would see the air pressure in the areas around the car and examine if it's beneficial. Usually, what we want is a car that has balanced air pressure around it, so that there's no vacuums forming. The blue color here indicates that it's at extremely low pressure, while the red color here indicates that it was extremely high pressure. So from looking at this picture, you can already tell there's going to be a lot of drag because of the blue color, low pressure region behind the car. And there's also going to be forces acting on the car from the front. Because of the high pressure here, it will cause the nose to go upwards. And that's a lot of the things we did in F1 schools. We had to do a lot of these analysis, and it became extremely complex, which is why we relied heavily on our collaborations to help us understand what we were doing. And as you can see here, this was the final design of the car. We actually used rendering software. We took this 3D model and we rendered it to look like a real object, like a real car in real life. And we added colors, we added logos, and we took pictures from several angles. This was mostly to help market the team and also help sponsors get an idea of what the final product will look like. You can also see at the bottom here, this is a technical drawing of the car. We also had to do that. And all of this contributed to the engineering of the car. A lot of the engineering in this car was done in parts. We had to do things separately so that we won't make mistakes. So the cat was done all beforehand. We would do that first. Would slowly design the car with all the ideas we had, and then we go to computer aided engineering. And this took a long time to we carefully and meticulously tested every single possibility. And only when we were confident in the final product, that's when we started rendering and creating the technical drawings. Right. So this is what we did in F1 schools, and innovation in the car was extremely hard. See, F1 schools have been going on for an extremely long time, and a lot of teams have already innovated a lot in terms of the car. There were things such as LERS, which is what's a energy conservation system. What they would do is they would put it behind the car near the canister, so that the energy released from the canister would be conserved and the car can go faster. And the other
Hi again.
innovations included.
Sorry. Hi again, Mr. Wan. We have 5 more minutes until your slot ends, so just continue and wrap it up shortly.
Okay, don't worry. This was the final slide actually. As I was saying, a lot of the innovations on the car have already been done. A lot of people have done research about the wings, about the body of the car, about the aerodynamics, and it becomes extremely difficult to innovate at that stage. Especially for students like us, we don't actually have a lot of time in F1 schools. From nationals to world finals, we actually have only a year to design, to test, to analyze, to create the final design, to promote our team. All of that has to be done within a year, which is not a lot of time. This is why innovation becomes harder as time goes on. Innovation when it comes to the car becomes harder. This is why in SMK Section 9 we have this tradition of going to F1 schools, and a lot of the seniors actually save all the data, all their documents, so that the future generation can use it. I'm hoping Keris Racing is using a lot of my research for their car, because it took a lot of time for me to do it. It saves time because even when I was in F1 schools, I relied a lot on my seniors too. I asked them a lot of questions. I asked them about their insight. I even had them present to me what they did during their time in F1 schools. And all of that contributed to the car, it contributed to the project, and the cooperation between all these different parties, not only UITM, we also cooperated with UTM, Serusha, we cooperated with companies such as CIMB for the financing, and all of this contributed to the success of the team. And it's one of the reasons how we managed to win the Innovative Thinking Award. Not to mention the hard work from Cikgu Kashnani, Cikgu Amirul, who were always there to help us and give us guidance. All of these contributed, and it's very important. Again, I would like to highlight, because this is extremely important, that collaboration really is one of the key reasons innovation happens. All right. I think that's it. Thank you very much, everyone. Q&A session.
Don't worry about it. All right. So now our Q&A slot is now open. So please comment down your questions that you have for Mr. Wan down below. Oh, there's already one here that's very interesting. It intrigued me just now. Again, from Sir Liv Koof. I'm so sorry if I'm butchering that. I was wondering, how much energy do we use to recycle plastic? Since most of the energy produced generates CO2 emission, recycling plastic is saving the earth, but melting is generating CO2.
That's actually a really good point. It does take a lot of energy because I think for bottle caps it was high density polyethylene, which has a high melting point, and it takes a lot of energy. But in my opinion, the energy that we save from the recycling is not only benefiting in terms of energy conservation, but it also helps with the environment in terms that we don't leave waste to be decomposed outside. So recycling, yes, it does, because we're going to be reusing the material again. But at the same time, it ensures that all of the materials and energy is used efficiently, and the efficiency is actually important, especially for the environment, because we don't have unlimited resources. We need to use what we can.
Okay, so the next question is from Fauzia binti Muhammad Shah. She says, how to mount the bottle cap in a safe way?
Oh, if you want a safe way, you should use an injection molding machine at UITM, because there's a lot of safety mechanisms inside the machine itself. So I remember back then when we were in UITM, we would be wearing gloves and everything, and we would be putting the plastics into a container inside the machine itself. So all the melting that was happening, all the heat generated was inside the machine, and it couldn't affect us. So that's probably the safest way. The most dangerous way is taking a bucket and heating it up with all the plastics inside. I wouldn't recommend that.
Okay. So this is another question. It's more personal, but I think so it's a very important question. So Hakimi bin Hafizullah says, is F1 in school fun to you? So maybe you could talk more about your experience in F1 in school, and like what did you gain from that is still sticking with you till today?
Okay. Well, there are moments that is fun, and there are moments when it becomes extremely difficult. And I think it's not about having fun for F1 in schools. It's because the experience you get, you will never get anywhere else. It's a challenging competition, and it really treats you like an adult, where you're forced to think about all these problems. And most of the things that stuck with me from F1 in schools is a lot of the soft skills, the ability to talk in front of crowds, the ability to present my ideas, and a lot of the engineering mindset that I got from ITM, the ability to think about things in terms of problems and solutions, which is why I started the presentation with my objectives. Because once you know your objectives, you know you have to start finding the solutions to help meet those objectives. So yeah, I would say F1 in school is fun, but you need to be prepared for what comes, what challenges come.
Definitely, I totally agree with that. With every situation that you enter, there's always a give and take, but definitely there's more pros than there are cons. All right, so there's another one here from Wan Ling. She says, maybe it is out of topic, can we change bottle caps into the material for 3D printing or pen?
Oh, that's actually really interesting. But currently, from what I know about 3D printing, is that a lot of these machines, they have filaments. So these plastics have already been turned into materials that can go into the machine. So when we melt the bottle cap, it's going to be just liquid plastic. And from there, you have to shape it into something usable for 3D printing or 3D pen, which is quite difficult to do without the proper molds or the proper machinery. So although it would be possible, and I think a lot of people who have 3D printing machines actually recycle their plastics to reuse again. So yeah, I think it's possible. It just depends on a few factors.
Yes, exactly. Actually, regarding this question, I saw in the chat box, in the comment section, there were a lot of people saying that they should use this idea for their school or recycling plastics from their school, and I totally agree with that. Maybe you can recycle school plastics or like the students' waste and make them into souvenirs from the school. I think so that'll be such a great idea, especially um, uh, wanting to reduce waste. Okay. Is there any more questions in the chat? Can you recommend what the good of this car? I'm not really sure what this means.
Um, I also don't quite know what understand what this means.
I
I'm
think
assuming.
so. He's trying to say, like, what is the quality of the car that, like, you would want?
Ooh, oh okay. The quality of the car, the characteristics, right?
Yeah, something that the objectives of the car that you
Yeah, okay.
that you
Right.
want to achieve.
So in F1 schools, the goal, the objective is to create the fastest car, and there's a lot of forces that are on the car as it's going through. So there's actually a canister at the back of the car that provides the majority of the energy for the car to move in its racetrack. And the important thing to note here is that the car itself is not creating any of its motion. It's being pushed by the canister. So our job is to design it to be streamlined and to be affected by the least amount of forces possible. So this is why a lot of people use the word aerodynamic. When you design a car to be aerodynamic, what it means is that you want to reduce the drag by making sure the movement of air around it is smooth and it doesn't create vacuums, because those vacuums would cause a drag on the car. And that's one. There's also another thing, another concept, which is the drag formula. And one of the things in the drag formula is the cross sectional area of the car. So this analogy I remember is when you're in a car and you're driving straight. If you put your hand outside and you put your hand just like this, okay, if you put your hand like this, you would feel like there's a lot of force pushing it backwards. That's because the area of your hand is big, so the air pushes more on your hand. But if you angle your hand like this, what results is there's a smaller cross section area, so your hand doesn't get pushed back as often. So that's what we tried to do with the design of the car. We tried to reduce the cross sectional area to reduce the amount of surfaces the air is pushing on. There's a lot more, but it's a complicated design, so I don't think I'm gonna explain all of them.
All right, maybe they'll
Any
have to contact you personally. Anyway, since we're running out of time, I'll have to close the Q&A slot. What a great selection of questions from all of you, but I'm afraid we're running out of time. It was such a pleasure to sit down and talk with one of our prominent speakers. Definitely, thank you so much, Ishraf. I love how today we were highlighting a lot of points regarding how we can improve ourselves and also help in contributing to make the world a better place. Kiss, take it away.
So I wish we could chat a little bit more, but I'm afraid our webisode is coming to an end, so that I think we should wrap up this webisode, Arina.
Yes, but before we can do that, we would like to say thank you to those who made it with us to the end of this webisode.
But don't go yet because before we end, kepada para guru tidak kira dari sekolah mana atas jemputan JPS, kami akan share link Google Form untuk anda catat kehadiran para guru bagi mendapatkan mata SPLK PM anda. Please do find the link in the comment box. In the bracket, it will have 4 teachers.
Yes, so we'll share the link in our comment box. Please find your way to that link so it can mark your kehadiran. It has there in the bracket for teachers so you don't get mixed up with the students later. And for the rest of you that stuck with us to the end, click the provided link that will lead you to a Google form, fill out the questions provided, and you should receive a certificate of appreciation through email that will be valid to give you co-curriculum marks. Again, in the bracket, it will have 4 students.
Alright, we'll give you time to actually click the link and fill in the form.
Yes, definitely.
Dan maka dengan itu berakhirlah sudah webinar series Inside the Minds with Keris Racing second episode. Terima kasih kami ucapkan kepada semua. Semoga berjumpa lagi pada episod akan datang.
Yes, definitely. Thank you guys so much for joining us. The most views that we had today was around 180 of you guys. So thank you so much. And throughout our last slot, there was 150 of you who stayed to the end. So thank you so much, everyone, for joining us today. Maybe any of our speakers, do you want to say anything for the end of this webisode?
From 3D Gen, hope we can continue to collaborate again in the future.
Will do.
Definitely. It was such a fun slot that we had with 3D Gens. All right. Thank you. Thank you so much, everyone in the chat, especially those who were very, very active and very friendly also. Thank you so much for organizing this free webinar. You're welcome.
Thank you, Dr. Isha and 3D Gens for continuously support the team.
Thank you everyone here for supporting us and for believing in us, even though it was very last minute. It was a successful webinar, I can say. It was a very successful webisode for today. Thank you.
Okay, thank you to all of you. Okay, bye. See you next webinar episode.
Okay, thank you so much for Fazila.
Okay, bye. Thank you all for all. Thank you to all presenters also. Okay, bye. Assalamualaikum.
Thank you. Bye. Waalaikumsalam.
All right. Okay, bye.
Thank you. All right, so our webinar has officially ended. Thank you so much to our speakers who joined us today and for the team in the background that maybe the viewers cannot see, but they worked very hard as well, preparing everything so that today's event could go smoothly. Thank you, Aiman. Thank you, Iman. And thank you, Kadish. Thank you, everyone. Maybe Puan Rasina, do you want to say anything? Just wait, let me add her to the stage.
Much everyone in the chat, especially those who were very, very active, very friendly.
Hi, Puan Rasina. Do you want to say anything to our guests whom are leaving?
Thank you so much for organizing this free webinar. You're welcome.
Terima kasih kepada Dr. Izhar dan Profesor Nes.
I'm here for supporting us and for believing in us. Very last minute.
Thank you, guys.
It was a successful webinar, I can say.
I hope the link tak tenggelam.
Aiman boleh pasang balik kot the music.
Yes. You're welcome, everyone. Thank you. Thank you. Welcome, Ryan. Welcome, Hakimi. You're welcome, Rafiki. You're welcome, Sharpit. This is an interesting program. Thank you. Thank you. You're welcome. You're welcome.
Great job.
Thank you so much, Farnesina.
Just now, can you hear me?
I'm not sure, but we can definitely hear you